Hi everyone, we are going to start our new unit today. So we are going to be looking at trigonometry. We're actually going to spend the next couple of units on trigonometry. Our first one, we're going to review a lot of our basic trig ratios and laws. So today we're going to take a look at using right triangles. And when we're using right triangles, we are using SOHCAHTOA, our three primary trig ratios for trigonometry. And this is all based on the relationship between sides relative to an angle. So if we're going to take a look at angle C here. So angle C is theta. Theta is a symbol for missing angle. From theta here, we want to name our sides: opposite, adjacent, and hypotenuse. Well, we know that our hypotenuse is always our biggest side in our triangle across from our 90-degree angle. Where we are looking at opposite, theta here means opposite has to be over here and adjacent is here. Remember, adjacent means beside. Technically, we have two sides beside angle C, but this one has to be the hypotenuse, which means this one has to be the adjacent. And our ratios then get set up. Sine of theta, or our angle, is opposite over hypotenuse. Cosine ratio for theta is adjacent over hypotenuse. And tangent of theta is equal to opposite over adjacent. Okay, so each of our ratios works with an angle and two sides. As long as we know two of those pieces of information, we can find the third one. The other thing we want to keep in mind for right triangles is that we can use Pythagorean theorem. So if we have two sides of our triangle and we want to find our third one, we can always use Pythagorean theorem. We can also use the fact that angle A, angle B, and angle C have to equal 180 degrees. Remember, this is our ASTT, or angle sum of a triangle theorem. So taking a look at using those things to solve missing pieces of triangles. Example number one, we're going to find x. So we're going to find a side. We're going to state lengths to one decimal place, angles to the nearest degree. That's our general rounding for trigonometry. So taking a look at our angle that we know, we are given our opposite and we need to find our hypotenuse, which means that we have to use our sine ratio. So sine of a 36-degree angle is equal to 4.2 over x. Remember, we cannot solve for a variable on the bottom of a fraction, meaning that we have to take the x over to the left-hand side and multiply. At the same time, we can bring our sine 36 over to the right-hand side and divide. So when we do that, we get 7.1. We make sure we put our meters in there. So x is equal to 7.1 meters. And it does make sense. X has to be the largest side. It is the hypotenuse, so it should be bigger than our 4.2. Part B, now we want to solve for an angle. So we can still use a variable. We can use theta for missing angles. We want to set it up that we are looking for a ratio of x. Now, we know that 23 is our, opposite side. And our 15 is going to be our adjacent because it's right beside our angle, and we know that one has to be the hypotenuse. So using opposite and adjacent, we know that we have to use our tangent ratio. So we're looking for the tan of angle x, and that has to be equal to 23 over 15. Now remember, a tan ratio is going to be a decimal, which we're going to get when we do our 25 divided by 15, but we want to do that all in one step in our calculator so we don't have to round. When we are looking for an angle, we need to do our inverse tan. So we're going to do our shift tan for most of us in our calculators, and we're just going to make sure that we put our 25 divided by 15 in brackets so it finds the decimal before it does our inverse tan. So you may have to put 25 divided by 15, use that decimal, then do inverse tan. You may have to do inverse tan first and then divide by 25 divided by 15, depending on your calculator. So because we're talking about an angle, we are going to use degrees, and this is where you want to make sure as well that your calculator is in degree mode. When we do this, rounding to the nearest degree, we get 57 degrees. Example number 2 says to solve each triangle, and we want to state all answers to one decimal place. Well, solving a triangle means to find all of our missing angles and sides. So when we're done, we should know all 3 sides and all 3 angles. And the first thing we're going to do whenever we're doing a question like this is draw a diagram. We want to be able to see what we have and what we need to find. So we're always going to start with drawing our triangle. So we have triangle LMN. We need to make sure that we label angle N first because that's our 90-degree angle. The other angles, it doesn't matter as long as we label our triangle appropriately. Remember that capital letters denote our angles and lowercase letters denote our sides. Our sides are opposite, so side N, which is 12.4 meters, is opposite to angle N. So N is over here, which is 12.4 meters. We have our 90-degree angle, and we know that L is 60.2 degrees. So looking at what we have here, we need to find everything. Well, the easiest thing to find right now is angle M, because we know that our 3 angles in our triangle have to add up to 180. So we're going to subtract the other 2 to find out that M is equal to 29.8 degrees. And notice that we are leaving it to one decimal place because the question told us that we wanted to round all of our answers to one decimal place. So we have angle M now. We want to still find side M and side L. So let's start with side L. We always want to, when we can, use given information from our question, just in case we've made a mistake finding other things. So focusing, the given angle we have is angle L. If we want to find side L, that's going to be our opposite, and we have our hypotenuse here. So we're going to use our sine ratio. So sine of 60.2 is equal to opposite, which is L, over 12.4. We're going to take our 12.4 over to the other side to solve for L. When we do that, we find out that L is 10.8 meters. Now we still need to find side M. Still using angle L, we know that we need to find our adjacent. So this time we're going to use adjacent and hypotenuse, which means we're going to use cosine of 60.2 is equal to M over 12.4. Again, taking that 12.4 over to the other side to solve for M. So when we put that into our calculators, we notice that we get 6.2 meters. And we can make sure that we put little dots above our equal signs because we know that we've rounded both those answers. We didn't get exactly that value. And anytime we're looking for multiple things in a question, we want to make sure that we do a therefore statement, summing up everything that we figured out here. And we know that we figured out angle M is equal to 29.8 degrees, side L is equal to 10.8 meters, and side M is equal to 6.2. Again, uppercase denote angles, lowercase denote sides. One more example for today. We have triangle DEF. Again, we're going to draw our diagram to start with. So that we know exactly what we need to find and what we have. And we know that angle E is our 90-degree angle. And we label appropriately. We know side D across from angle D is 7.2 centimeters. We know angle F across from, side F across from angle F is 5.3 centimeters. So we can see that we need to find angle D, angle F, and side E. Notice that we can use Pythagorean theorem here. We know that E squared is going to be equal to D squared plus F squared. And we're going to calculate E by taking 7.2 squared plus 5.3 squared, and we're going to square root that entire answer to figure out what E is. So we can do that all in one step in our calculators. Now, if we need to use this answer in following steps, we want to keep more decimal places. We do have enough information to find our angles without using side E, so we can round to one decimal place here, and when we do that, we get 8.9 centimeters. Taking a look now at side D. From side D, we have opposite and adjacent, so we're going to use tan. So tan of D is equal to 7.2 over 5.3. And again, to calculate angle D, we're going to do our inverse tan of 7.2 divided by 5.3. And when we do that, keeping to one decimal place still, we know that angle D is equal to approximately 53.6 degrees. Now, we could also use tan to find angle F. It would just be the reverse, that our opposite would now be 5.3, our adjacent would be 7.2. But we can now use the fact that our angles have to add up to 180 to find angle F. So taking away the other two, and again using ASTT to do this, we know that F is equal to 36.4 degrees. And again, just doing a quick therefore statement to sum up everything that we've figured out here. Side E is 8.9 centimeters. Angle D is 53.6 degrees. And angle F is equal to 36.4 degrees. Okay, so that's a quick review of our primary trig ratios using those four